What's up everyone, this is Mr. Lang, and in this video I'm going to be helping you through some review questions on quadratics. This is a homework helper video. And I broke up this topic, quadratics, into two parts. It's kind of a big topic. We spent a lot of time on it, so I thought two videos would be good instead of one really long one. So in this video, I'm going to do questions 3, 5, 6, and 9. These are general parabola problems, dealing with the general form of it and interpreting vertex, that sort of thing. In the next video, I'm going to do numbers 8, 10, 11, and 12. These are the ones where you have to solve by factoring and completing the square. I thought that deserved its own video. Then it's your job to finish the worksheet and do the online quiz. So let's get started with question number 3. We got a multiple choice question here. It says, which of the following quadratic functions, typo there, has a maximum value of 16? And if we're talking about quadratic functions, we know we're talking about parabolas. And the only way a parabola is going to have a maximum value is if it opens down. So a maximum value of 16 would be here, like this. So think about what would cause a parabola to open down, and it's if that x squared value, that first value, is negative. So I can automatically rule out number 1. Number 3, the x is positive. I don't care that this is minus 16. This x is positive and it gets squared, so we're going to have a positive x squared. Same exact thing with number 4. It's positive x, it's being squared. So the only thing left is number 2, and this actually works because the minus x squared, this is kind of like out of its normal form, but the x squared is negative, so it's got to be answer number 2. That's the only way this would work. Cool, on to the next one. Question number 5. The quadratic function f of x has one zero at x equals negative 5 and a turning point at 3, 10. What is the value of the other 0? I don't do this in kind of a solving way or some fancy algebraic way. I actually just kind of draw a picture. If I were to kind of just draw a quick sketch of the XY grid here, it has 1 0 at x equals negative 5. So if this was negative 5, one of its zeros would be right here. And if here's positive 5. It says the turning point is at 3, 10. Okay, so 3, 10 would be somewhere up here like this. And so it's going like this. And it's going to come down somewhere over here. Now, I don't know exactly where this is going to come down right now, but we can figure it out. Well, parabolas are symmetrical. So we know that from 1, 0 to here, well, this is a distance from negative 5 to positive 3. Well, how far is that? Well, negative 5 to 0 is 5, of course, and then another 3. Gives me 8. So there's 8 distance from the 0 to where this vertex would be. So I better have another 8 to go to here where this one would hit. Well, from 3 and I add 8 to that, it's going to be 11. So it's got to be, my x has got to be 11 over here. And that is answer number 1. There may be other ways to do this. You may be able to plug in, x equals 5 into the general equation of a parabola, but I think this is just as easy to do. And remember, on the Regents exam, you get a piece of graph paper, kind of a scrap piece. You can use that for something like this, so you don't have to draw such a kind of a crude sketch like I have here. Anyway, but this is multiple choice, so we just got to get the right answer. Anyway, let's move on to the next one. Number 6. It says, which of the following is the turning point of the function y equals quantity x minus 8 squared minus 2. Remember, turning point means the vertex. And the way this is in vertex form, which is good. So what this means is that this tells you the x value, this tells you the y value. But the only trick is you got to remember the x value is kind of opposite. So the vertex for this is going to be positive 8, but the y stays exactly the same, negative 2. Remember, you just take the opposite of that. So 8, negative 2 is answer number 1. That's it with that. If you remember vertex form, it's cake. And number 9. If the quadratic function f of x equals x squared is graphed below, along with the quadratic function g of x, which of the following could be a correct equation for g of x? So we've got f of x here, and g of x, it's not only flipped, but it's a little bit narrower. So we know if you want to flip it upside down, it's got to be negative. So I'm going to eliminate answers number 1 and number 3 because those are both positive. So it's either negative 2 or negative 1/2. And how does it go negative? I'm sorry, how does it go narrow? To go narrower, you actually have to increase the a value in front of the x squared by more than 1. And 1/2 would actually make it wider. So we're actually looking at number 2 here. And here's another way you could do it. You could actually put both of these up on your calculator, you know, f of x equals x squared, and then put the negative 2x squared. Well, actually, you know what? Why don't we do that? Just as a nice, easy way to check. I'm going to put the x squared, and then right below it, I'm going to put the negative 2x squared. And we're going to see if our graph resembles what we got here. There's x squared. There is negative 2x squared, and you can see this is pretty much an exact copy of this. So that's a nice, easy way to check it. It takes 2 seconds. So that is it for this video. Be sure to tune into video number 2 for quadratics. That's going to help you out with the solving by factoring and completing the square. Anyway, thanks for listening.